Okay, guys, Abi the tutoring here. We are great to simplify the complex. You know, those things that you are struggling to understand, we have a grace to make you understand. Okay, so cool. We are doing Euclidean geometry, grade 11. Euclidean geometry, grade 11. Euclidean geometry. Okay, good. So, this is one of the topic that most learners seems to be struggling with. Okay, it's not really a difficult topic, but then why do most of you struggle? It is because of you forget what you have learned prior. You forget what you have learned in lower grades like grade 8, grade 9, grade 7. Remember? And you have so many theories. You have theories about lines, you have theories about triangles, you've got theories about quadrilaterals or properties of quadrilaterals. So those ones, if you forget them, this topic might be very challenging for you. Okay, so you mustn't learn to forget. Like, for instance, if you are given a straight line like this, and then you have a line that intersected like that, you know that these two and this one and this two, they are supposed to add up to 180. Okay, so but then sometimes you can really get stuck on a Euclidean geometry problem just because of you forgot that when you add the two angles on a straight line, they add up to 180. So those are the things that I'm talking about that you seem to forget. Okay, so without any waste of time, let us start with our lesson. Okay, so what are we going to learn? So we are going to learn about circles. Okay, so we are going to learn about circles, but then before we go to learn about circles, I just want to bring it to your attention that you need to remember lines. How do lines works? Lines and angles. Okay, lines and angles. Number 2, you still need to remember triangles. Okay, how do triangles work? Number 3, you need to remember the properties of your quadrilaterals. Do you still remember quadrilaterals? Quadrilaterals. This will help you to answer most of the questions in this grade, which is grade 11. Okay, and then the things that you're going to learn in this grade 11, they are going to be very important, very important in metric. So in metric, you might not learn a lot of things. Actually, you are not going to learn a lot of things. You're just going to learn some few theorems, and most of the questions that you answer in metric, they are based in what you have learned in grade 10 and grade 11. Okay, so lastly, of which this is what we are going to learn, myself and you. 4, we are going to learn about circles theorem. Okay, so in grade 11, we learn a lot about circles theorem. I think they are around 9 or 10, somewhere there. Okay, all the theorems. So you need to know those theorems, and then you will see that geometry is such a nice topic, Euclidean geometry to be specific. Okay, cool. So let us just do touch-ups on whatever that we spoke about so far. We spoke about lines and angles. Okay, so quickly, let us go through it quickly. You know, we're just gonna do touch-ups there and there. So like I said earlier on, if you have a straight line like that, and then you have a line that intersects your straight line, here's your angle 1, there is your angle 2, right? And then what can you conclude about this? Let's say that this point is A there. Then you can simply conclude that angle A1 plus angle A2 are equals to 180 degrees. Okay, And then what's your reason? Angles on a straight line. Okay, you can just reason it like this. Angles on a straight line. Okay, and what else? Let's say that we have angles around the point. Okay, so here's your point. You have a line going this side, you have another line going this side, and another line there. So let me call them A, B, and C. Okay, what can you conclude about this? You can simply conclude that angle A plus angle B plus angle C, all of them gives you 360 degrees. Okay, and then what is your reason? Angles around the point. Angles around a point. Or you can just say rev. Okay, this is a shorthand for revolution. You just write rev like that. And then what else do we need to know? Let's talk about vertically opposite angles. So if you have a line like that and another line like that, you have a shaded that dot, the big dot there, which is shaded, and then you have this ones as well. Okay, so you know that this angle from this side is equals to that angle, and then this angle is equals to that one. Okay, so actually let me give them names. Let me say A, B, C, and D. So you can simply conclude that angle A is equals to angle C. And then what is your reason? Your reason is simply going to be vertically opposite angles. Okay, so your reason, you just say angles. So vertically opposite angles. Okay, then remember we are talking about lines. So far we haven't spoke about anything. I'm just reminding you of what you should remember. Okay, so and then now we have parallel lines, of which I'm not going to explain a lot about parallel lines. I hope that in grade 11 you understand what are parallel lines, and then what is a transversal line as well. Okay, I'm not there, I'm not teaching there, unless if you need extra lesson on that, then I can explain to you that. Okay, so when we talk about parallel lines, we talk about the lines which are equidistant. Okay, what do we mean by equidistant? Meaning that no matter what happens, they will never ever intersect. Okay, why? Because of they are the same distance far apart. Okay, and then how do we know that lines are parallel? We see them by this sign. If you do not see these arrows here, you can never conclude that those lines are parallel. Okay, guys, if you don't see arrows, don't conclude that those lines are parallel. You need to be able to see those arrows, or you need to be told, then you can simply conclude that your lines are parallel. Okay, so when we talk about parallel lines, there are so many things that you can conclude about them. Okay, so this is our transversal line. I'm not going to explain what is a transversal line. Line AB and line CD. Okay, so now what can we say about parallel lines? For parallel lines, we have what we call alternating angles. So if I say this angle and that one there are alternating angles, right? And then what can you conclude about alternating angles? Alternating angles are equal. Okay, I'm not teaching this. If you want me to teach it, you can text me, and then I'll definitely be able to help. Okay, so I will explain almost every detail, but then now I'm just passing. So I'm talking about alternating angles, and then we also have what we call co-interior angles. Okay, co-interior angles. So now whenever I talk about co-interior, I'm sorry about that, I don't know why it doesn't want to write co-interior angles. Co-interior angles, what am I talking about? So now I can just decide to say that, I'm sorry about that. So this angle here and that angle there, they are co-interior angles. Okay, and then there are other angles which we call them corresponding angles. Okay, corresponding angles. Okay, what about corresponding angles? So corresponding angles can be this angle here and that angle there. Okay, like I said, I'm just passing by. I'm not going to teach a lot here. Just the things that you need to remember. You have to make sure that you remember this. Okay, and then from there, that is what you need about the parallel lines. Okay, so we spoke about vertically opposite. Okay, we spoke about parallel lines, of which they have three properties, which is co-interior angles, alternating angles, and corresponding angles from parallel lines. Okay, so three, right? And then we have vertically opposite angles, that's 4, and we have angles around a point or a revolution, that's 5, and we have angles on a straight line, that's 6. Okay, so there are about 6 things that you need to know about the lines. Okay, so let's just leave lines and then let's talk about the triangles. Okay, so we have different types of triangles, of which I'm also not gonna go deep discussing them. Okay, triangles, we have about sorry about that, guys. As for triangles, we have about let's say 4 of them. Okay, so we have a scalene triangle. Know the properties of scalene triangle. We know isosceles triangle. Know the properties of isosceles triangle. We have equilateral triangle. Know the properties of equilateral triangle. We have right angle triangle. Know the properties of a right angle triangle. Okay, so scalene, it is that type of a triangle, no sides that are equal in length. So, and if there are no sides that are equal in length, it simply means that even the angle can never be equal. Okay, an isosceles triangle, we are talking about that triangle that have 2 sides equal, and if those 2 sides are equal, they will yield 2 angles which are equal. Okay, and we have equilateral triangle. Equilateral triangle, it's one of my favorite triangle. All the angles are equal. All 3 angles are equal. Each of them is 60. Okay, and then if all the angles are equal, then you can conclude that all the sides are also equal. Okay, so it is a triangle that has 3 sides and 3 interior angles equal. Okay, and then right angle triangle, it is any type of a triangle having one angle being 90 degrees. Okay, so those are the ones that you still need to remember. But then the property that I would just like to discuss here, it is the property of some of the angles of a triangle. Okay, some of the angles of the triangle. I want to talk about some of the angles of a triangle. Okay, so let's say that you have a triangle like that. Then you have A, B, and C. Okay, so you can conclude that angle A plus angle B plus angle C, all of them are equal to 180 degrees. And then what will be your reason here? Your reason is simply going to be sum of angles of triangle, like that. Okay, and another property that you need to remember with the triangles, it is this one. Okay, if you have that, oh sorry, let me start it here and go like that. It doesn't want to give me a straight. Okay, cool. You know what I'm gonna do? I'm just gonna draw a triangle like this, and then from there I can extend it from here. Okay, so now check my triangle, guys. There are so many misconceptions around this one. Okay, let's say that we have A, B, and C. Okay, so if you have a triangle like this, you can conclude that angle C there, angle C there, it is equals to angle A plus angle B. Okay, and then what will be your reason? Exterior angle of a triangle. Okay, this is a reason enough. Okay, exterior angle of a triangle. Now guys, the misconception is this one. Okay, so notice that this line that extend, let me just use a different color. Notice that this line that extend, guys, it extend with a straight line. Okay, so check, it has joined this line like that. Okay, it didn't disturb anything, it was just straight like that. There's no any bending. Okay, so I don't want to see any of you guys applying a exterior angle of a triangle on a shape like this. You see, there's a bend here. Okay, it's bending, so you are not allowed to apply that. That line must overlap straight. It can radiate from here like that. You see, as long as it gives you the straight line vibes. Okay, even here it can go like that, as long as it gives you a straight line vibe. And where else? And yeah, and also there. Okay, so I hope you guys understood this. Okay, then what else do you know about triangles? You can also talk about what do we call it? A right angle triangle. Remember, right angle triangle, I said it is a triangle that has one angle being 90 degrees. Okay, so whenever you see this type of a triangle, then you know that theorem of Pythagoras can come to help you. Okay, theorem of Pythagoras, or Pythagorean theorem, Pythag. Okay, so you can apply theorem of Pythagoras whenever you see a triangle like that. Okay, and what else do you still need to remember? You need to remember congruency. Do you guys need to remember congruency? Congruency, and then after the congruency, you need to remember the midpoint theorem. Okay, so about triangles, you need to remember congruency. Okay, so congruency, remember conditions of the congruency. All right. And then the other one, it's more like this, an included angle there and two sides like that. And then the other one is more like that, when you have one side and two angles like that. Okay, congruency and the midpoint theorem. Okay, and then from there you learn the properties of quadrilaterals. Okay, so for 10 minutes guys, I just want to introduce our lesson. Okay, this is very important. The reason why I'm making this video, it's because of what I'm going to do now. All of these things were just a revision of all the things that you need to remember. Okay, so now today guys, I just want to talk about a circle. Okay, let's talk about circle. Let's understand circle first before we talk about it. Okay, let's draw a beautiful circle. Which color can I use? Let me use yellow. Let's draw a beautiful circle like that. Wow, it's so beautiful. Let's just assume that the center is there. I hope it's the center indeed. Okay, so firstly, let's talk about the radius. Okay, so what is a radius? So this is a part of a circle which we call a radius. Okay, let me just write the radius. Okay, so guys, what is a radius? A radius, it is a line from the center to any point on the circumference of the circle. Okay, so remember that it must emanate from the center. A line from the center to the circumference. Okay, so this yellow thing here, we call it a circumference, guys. Okay, so and then that one is a radius. Actually, let me use different colors, okay, so that you can really be able to distinguish them. Let me use a red color for radius, right? And then even here, let me just write with the red color. So this is our radius. Okay, and let's take blue. We have a diameter, guys. Do you guys know what is a diameter? A diameter, it is a line passing through the center of the circle. It is double the length of the radius. Okay, it is a line passing through the center of a circle. Okay, from one circumference to the other circumference. You see, it passes through that center. And then if you check it, it is double the radius. Okay, so what is it? It is a diameter. Okay, this is a diameter. What else do we need to learn about the circle? We need to know what is a chord. Okay, so guys, I'm just going to show you a chord on our circle there. A chord, guys, is a line with endpoints on the circumference. Okay, any line with the endpoints on the circumference. Okay, so this is a line. From there to there. You see, this is a line from this point to that point. Its endpoints are on the circumference, and we call it a what? A chord. Okay, a chord. And beside a chord, guys, we have a secant. Okay, so please do not confuse a chord and a secant. Okay, a chord and a secant are not the same, guys. Let me use a pink. A secant and a chord are not the same. So with a secant, it is a line passing through points on the circle. Okay, it passes. It's not the same as the chord. The chord ends at the circumference. Now the secant crosses the circumference. Okay, so we call that a secant. Okay, and the last one that I want you guys to learn, it is what we call a tangent. Okay, we have so many theorems about tangent. So guys, what is a tangent? A tangent, it is a line touching circle at one point. Okay, it is a line that touches the circle at one point. You see, it only touches it here. Okay, so we call that line a tangent. Okay, so I hope we understand what is a radius, what is a diameter. Well, radius, I know that most of you know it. Also a diameter, but then now I think the new terms here, it's going to be a secant. Did you guys know about secant? Do you guys know about the chord? The tangent, it's simple. Tangent, it has to touch your circle only once. Okay, guys. Then we can continue with our lesson. Now let us start with the first theorem. Okay, so before I group them, I'll group them at the end, but then now let us just learn the first theorem. Okay, the first theorem about a circle, okay, that you need to know. Let me just draw a beautiful circle there. Isn't it beautiful, guys? It's so beautiful. That's your center there. Okay, and then that's your line there. What do we call this line? I hope you didn't forget. It is what we call a chord. Okay, and then we have a line from your center joining your chord like that. Okay, So that line from the center joining your chord. Okay, so this is theorem 1. Let me just theorem 1 like that. Okay, so it moves from the center, it goes and joins your chord. Okay, then now what can we say about this? Okay, so theorem number 1 in a nutshell. According to the given circle sketched below, if OM is perpendicular to AB, which means M1 is equals to M2 and is equals to 90 degrees, AM is going to be equal to MB. Okay, let me just note this so that I can establish my case. And O there. Okay, so now the theorem 1, what it says is that if they tell you guys, if ever they tell you that OM, can you see OM is perpendicular to AB, if they tell you that they are perpendicular, then you can conclude, the conclusion that you can make is that this AM, it is equals to MB. But then only if you are told that OM, it is perpendicular to AB. How do they tell you that OM is perpendicular to AB? They will put this sign. Okay, so remember this sign. What does it say? It says that at that angle that it's 90 degrees. So if that is 90 degrees, even that one will be 90 degrees. So for the fact that they told us that OM is perpendicular to AB, let me say that this one is given. Let me say given. Given that OM is perpendicular to AB. Sorry about that, AB. So this one's, guys, it is the information that you are given. Now you have to make a conclusion. All this information was given. Now, if the information given says that if you are having a line from the center joining the chord, and then they are forming a perpendicular relationship, then you can conclude this, Bagiti. Conclusion. Conclusion. Then you can simply conclude that AM is equals to MB. Are we together, guys? I hope you got this. Okay, so this is the conclusion that you can make. If you are given the above, then you can conclude this. Quickly, let us do its converse. Okay, and then after we do its converse, we'll stop our class, and we'll definitely continue again later. Okay, so now let's do the converse of this. Now with the converse, if you are given a circle like that, and this is your center and this is your chord, remember, and you have a line from the center joining your chord like that, and this time you are given that this line, it is equals to that line. Okay, let us name it O A M B. Okay, so guys, remember earlier on you were given that these lines are perpendicular. Now you are given that they are equal. Okay, let us see. Let's say given, you are given that AM is equals to MB. Then you are allowed to say that if AM is equals to MB, then I can conclude this. Then I can conclude that OM is perpendicular to AB. Okay, then you can conclude that OM is perpendicular to AB. By making that conclusion, you simply means that now you can conclude that your angle there, it is 90 degrees. Okay, so they gonna give you one. It's either they're gonna give you this one. If they give you this one, when you conclude that one. If they give you this one, when you conclude that one. Thank you guys. I hope you watched this video up until the end. There's no work to do so far, but as lessons goes on, you will definitely get some work. So this is part 1, Euclidean geometry, grade 11. Thank you guys. Hope to see you in our next video. Bye.